Okay, chapter 10 in our book talks about geometry. And if you remember from your last year in geometry, there's a lot of vocab to start that off with. So, the first couple of slides, we're going to review what you learned last year in geometry. This particular section, point lines, planes, and angles. We are going to review the vocab, as I said, and then we're going to solve some problems involving angle measures and then those involving angles with parallel lines and transversals. So, to begin with, what is a point? A point is represented as a small dot and it has no length, width, or thickness. Okay, and it is denoted with the letter A. We have a line that connects 2 points along the shortest path, okay, meaning it's not going to curve, it's going to be always straight. And it has no thickness and infinite length, goes on forever and ever. And if you remember from geometry how many points determine how many points are on a line, they're an infinite set of points. That's what that infinite length is. Okay? A plane is a flat surface and has no thickness and no boundaries. It just extends forever in all directions. Okay? Then we have, to remind you, a line may be named using any two of its points. A half line is formed when a point divides a line. A ray is a half line with its endpoint included. And then we have a line segment, and that's a portion of a line. So a line goes on forever and ever. A line segment is one that has endpoints. Okay, we have angles. An angle is formed by the union of two rays. One ray is called the initial side. The other ray is called the terminal side. Okay, and remember the union of those two rays where they actually meet is called your vertex. And the different ways of naming the angle in this picture, you can name it by just using the vertex, which would be B, or if there's a number in it, you can use it with the number. Or if you use three letters, remember that the vertex has to be in the middle of the three letters. Okay, let's talk about measuring angles. They are measured by the amount of rotation from the initial side to the terminal side. Always in a, well, we won't go there. Angles are measured in degrees, symbolized by the symbol, the little circle raised above it. Hopefully you remember how many degrees are in a full rotation or a circle, and that's 360. So 1 degree is going to be 1/360th of a complete rotation. Then we have to remind you how to classify angles by their degree measurement. Okay, acute angle is a cute little angle, and that's an angle that is less than 90 degrees. A right angle, often denoted with a little square between them, is an angle that measures 90 degrees. Then we have an obtuse angle, and that's one that is more than 90 but less than 180. And then, of course, a straight angle is one that is 180 degrees. All right, special pairs of angles that you have talked about in the past. We have complementary angles, two angles whose sum is 90 degrees. To find the complement of an angle, you're going to subtract it from 90. So if I tell you or to ask you to find the complement of 70, then you're going to take 90 minus 70 and get 20 degrees. Okay? Remember, complementary is the sum whose 90. The other kind we have is supplementary, and those are two angles whose sum is 180. Again, you would subtract it from 180, so to find the supplement of 110, you're going to do 180 minus 110, which is 70 degrees. And in case you didn't get it last year, the complementary begins with a C. It comes before S in the alphabet. C comes before S. 90 comes before 180 when you count. So just a little something to try to help you remember which word goes with which number. Okay, so we have an example. Find the measure of angle DBC. So every time when you're doing these things, either the angles are going to be equal to each other or they're going to add up to a certain number. Okay, in this particular case, we have this little box, so we hopefully remember that these two angles are complementary and they will add up to 90 degrees. So if I know one of them, how do I find the other? I'm going to subtract from 90 degrees. So 90 minus 62 is 28 degrees. Okay, so these examples that I do out very quickly, I am doing them to show you this is what's in your book. So a lot of times if you have your book at home, you can go look at that and look through the examples. I'm trying to make you feel more comfortable in reading the book. But there's always a checkpoint problem to try yourself. So it'd be a good time to pause if you want to try it yourself, and then I will work out the problem. So we're going back to this figure, 10.8b. Let DBC measure 19 degrees. Find the measure of DBA. So DBC, they're telling me this is 19. They want to find this one. Regardless, the two angles are complementary, so they're going to add up to 90 degrees. So all I have to do, let's see if I can get this, is take 90. It's not working for me. Hold on 1 second. So we have 90 degrees, and we're going to subtract it at 90 degrees. We're going to subtract it from 90, and 90 minus 19. Pull out your calculator if you don't know. It's 71 degrees. So the measure of angle DBA is 71 degrees. Let's look at the next example. We have measure of angle ABD is 66 greater than the measure of angle DBC, and they are supplementary angles. So find the measure of each angle. Again, we have our solution. I'm going through quickly. It's in your book. You can look at it. You can rewind, speed it up, whatever you need to. But if the angles are supplementary, then we know that ABD plus DBC have to add up to 180 degrees. DBC we don't know, so we're going to write the letter X. ABD is 66 greater than X, so we write X plus 66. Still 180 degrees. We simplify the two. X plus X is 2X, and carry down the 66 and the 180. We're going to subtract 66 from both sides. 2x equals 114. Then we divide both sides by 2, and x equals 57. So the measure of angle DBC is 57. And how do I find ABD? Because I have to find the measure of each angle. I put 57 plus 66, and that's going to give me 123 degrees. So now we're going to try the same thing with our own. ABD is 88 greater than DBC. Find the measure of each angle. So as we did earlier, we're going to have plus x plus 88 equals 180. That gives me 2x plus 88 equals 180. Subtract 88 from both sides. 2x equals 92. Divide both sides by 2, and x equals 46. So I have to find the measure of each angle, so I'm going to say that the measure of DBC, that was my x, is equal to 46 degrees, and the measure of angle ABD is 46 plus 88, which is 134. So that's the answer to the question. All right, vertical angles. When two lines intersect and opposite angles are formed, the opposite angles formed are called vertical angles. And hopefully you can remember because you see a letter V in there. And you remember that all vertical angles are equal. So the angle on the left measures 68. Find all the other ones. So our solution from our figure, we see that angle 1 is equal to 68 degrees. And we know that angle 1 and angle 2 are going to add up to 180 because those are supplementary angles. So if angle 1 is 68 and I put it in there, then that means that angle 2 is going to be 180 minus 68, which is 112 degrees. And angle 2 and angle 3 are going to be equal to each other, so angle 3 is going to be 112 because of the vertical angles are always equal. So they give us one to do. Try it yourself if you want, and then pause, come back. So assume the angle on the left measures 57 degrees, find the measure of all the others. So I'm going to first say that 57 plus the measure of angle, they want the measure of that one. Hold on 1 second. So 57 plus the measure of angle 2 equals 180. So the measure of angle 2 equals 180 minus 57, which is 123 degrees. So that's the measure of angle 2, which is also the measure of angle 3, because those are vertical angles, and we already said the measure of angle 1 was 57 degrees, because it's equal to the one on the left that they gave you in the problem. All right, special line relationships. Parallel lines, remember, they're lines that line the same plane and have no points in common. These are our parallel lines in our picture. We have intersecting lines, two lines that are not parallel and have a point in common. So it would be this line and that one, or this line and that one. Those are intersecting lines. This would be the points that they have in common. And our transversal is a line that intersects two parallel lines. So that's the transversal in our picture. We have special angles that are formed when we have parallel lines cut by transversals. Tried to highlight it to make it easier. We have alternate interior angles. They are interior and alternate sides of the transversal. So they're inside the parallel lines. On opposite sides of the transversal, we have 3 and 6. And hopefully you can see that you also have 4 and 5. Alternate interior angles always are equal, so angle 3 equals angle 6, and angle 4 equals angle 5. Then we have alternate exterior angles. Exterior meaning outside the parallel lines. Alternate sides again being on different sides of that transversal, but outside your parallel lines. So we have 1 and 8, and hopefully you can see that we have 2 and 7. Again, they're always equal. So alternate interior angles, angle 2 is equal to angle 7. Corresponding angles, on the other hand, are you have one interior angle and one exterior angle, but they're always on the same side of the transversal. So we have 1 and 5, we have 2 and 6, we have 3 and 7, and we have 4 and 8. And again, these angles are equal to each other. So we're going to use these concepts to solve our last example, which is going to be example 5. Find the measures of all the angles. Keep in mind the order that you do this does not matter. Um, I have a particular way that once I find one, so if they tell me that, I've got angle 1 right here and angle 8 is 35 degrees. So that means I know that angle 1 is 35 degrees. I like to go find all the ones that are equal. So I'm going to do these two are vertical, and then I'm going to go to the opposite side, same side. So I know that angle 2 has to be 35 degrees. And then angle 2 is equal to angle 5. So angle 5 is 35 degrees. And then from there, it doesn't matter which one you do, whether you do 1 and 6, 1 and 7. These two are along a straight, all lines are straight, or form a straight angle, so they're supplementary. They add up to 180. So if I know this one, then I'm going to subtract it from 180 to get the answer. And then from there, I'm going to go vertical to 7, 145, alternate to 3, 145, and then vertical to number 4. But again, it does not matter the order that you do these. Okay, this is the end of the lesson. I do put in 2 other problems from your homework. These are the odd ones. You actually have the even ones that go along with this, but I just wanted to do them in case they might be a little challenging for some people. It says, use an algebraic equation to find the measure of each angle that is represented in terms of x. So when you look at it, again, they're either going to Whenever you're solving angle problems, they're either going to add to some number or they're going to be equal to each other. So you've got to look, are these two equal? No, they're not equal, but because of this symbol right here, I know that they're going to add up to 90 degrees. So I'm going to come over here, 2x plus 50 plus 4x plus 10 equals 90. Combine your like terms, 2x and 4x give me 6x, 50 and 10 give me 60, so that gives me 90. Then I'm going to move my 60 over, so I'm going to subtract 60 from both sides. 6x equals 90 minus 60. And then I'm going to divide by 6. So 30 divided by 6 is 5. Find the measure of each angle that is represented in terms of x. So, however you wish to look at this, if you want to say 4 times 5 plus 10, that's 20 plus 10. So this one is 30 degrees. And you can put it in here again. 2 times 5 plus 50. 10 plus 50 is 60 degrees. And you can check your answer and see that 60 plus 30 equals 90, which is what it was supposed to be. All right, so the last problem, again, they're either going to add up to a number or they're going to be equal to each other. These two are vertical angles, so they're going to be equal to each other. So I'm going to have 11x minus 20 equals 7x plus 28. Remember, we got to get the x's on the same side, the numbers on the opposite side, so I'm going to subtract 7x first, and that's going to give me 4x minus 20 equals 28. Get my numbers, constants on the same side, I'm going to add 20. So 4x is going to give me 28 plus 20, which is 48. And then divide both sides by our coefficient of 4. So x equals 48 divided by 4, which is 12. So when I put it in, I'm going to have 11 times 12 minus 20. 132 minus 20 is 112. And they're both going to be 112 because they're equal to each other. So that sums up our lesson. I hope you've written down any questions that you may have, bring them to class, or get started on your homework if you think it's an easy thing to do. You got your assignment ready. See you soon.